So sometimes we do have to do stuff that's a bit grim, that is less safe than we'd like to be. And OCaml and ReasonML lets us do this. It's also designed to really appeal to people who are already comfortable with the newer versions of ECMAScript, the JavaScript standard. So the syntax shouldn't be too unfamiliar. And if you want to write code that looks a lot like JavaScript, you can. Although ReasonML will also give you tools to write even better code if you want to. And I think the great thing when you start writing in ReasonML is that you get into this loop of absolute inconquerable type hype. So we've done types for a long time, but this is like next level types, right? We can start thinking about data structures first rather than code first. And there's been lots of famous people like Linus saying like, oh, you should always think about data structures, not care about code. And in reality, we do a very poor job of that because we think of our business logic first, and then we kind of like try and pipe the data from one end to the other and get something out right. And yeah, but this way, like we will see how the type system in Reason is next level. And we've been kind of using types for a while, right? So we've had Flow and TypeScript are probably the most popular variants out there. By show of hands, who mostly uses Flow? Wow, just that guy and you. Who here uses TypeScript mostly? Ooh. Two houses are like in dignity, okay? So this is like, it's been great. It's been giving us the ability to add a bit of type soundness to our lives, which is fun. But they're not perfect. Like Flow can't patch over everything, and itself is actually written in OCaml. And TypeScript isn't 100% type safe. And by type safe, it means like if something says, I am a variable of type blah, you can be 100% sure it's type blah. Because you can't be sure of that, there are a lot of optimizations you can't do. So let's write something really, really simple to demonstrate like some of the cool features of Reason. So let's imagine that we sell tickets to gigs, right? If we were to model what a gig is, we might try naively to go like, okay, let's say a gig consists of an artist and of a venue. And this probably looks very familiar to you if you like write Flow. You have, and the artist is a string, venue is a string, and you have a type thing. Fine. This is the shape of a record. Then we say, okay, we want to have a function that prints a message saying, hey, the artist name is playing at venue. So we write something like this maybe. Say, okay, a function is called printGig, and it takes a G, and then we say, okay, the artist, I'm going to do some string concatenation, is playing at the name of the venue. Now, if you're wondering, you might be wondering, wait, how on earth does this function, and due to the code lensing, we can see like we take in a gig and we put out a string, how does it know it's a gig? We never told it. We just declared a type somewhere nearby, and for this function, it's going like, oh, you mean this is a gig? I know. Well, this is through the type inference system that OCaml and ReasonML employs. It is absolutely incredible how good it is at holding your hand. It means you don't have to write verbose types. It is very, very good at figuring out what types you need, and it gets it right. If there's any way of interpreting the types in an order where the application logic might be wrong, it'll force you to clarify and won't compile. But most of the time, it means you're just flying along in absolute 100% type safety until you're not, in which case it'll stop you and go like, one sec, did you mean this or that? And that's really, really cool. Okay, so let's consider a scenario. Okay, so in the official user function, we pass in like what's called a record. It's a lot like an object, but immutable and lighter and has a few other perks. To this function saying artist is going to be called Muramasa, and the venue is going to be like that hipster coffee shop, right? Cool, and this compiles, the compiler is happy. But now we want to enter a universe where, okay, we actually don't know what the venue is going to be yet. It's TBD, right? Like we know the artist is playing somewhere, just not where. So we just try and pass in the artist without the venue. And JavaScript, what you'd get here is like the artist or Muramasa is playing at undefined. And undefined sounds like a pretty cool club, but it also might be the incorrect location. In Berlin, there's this really cool nightclub called like About Slash, and it's like on the old like Firefox lookup config options. Really cool place. But yeah, so I'm not unconvinced that a nightclub called Undefined doesn't exist. Yeah, okay, so this is wrong, and the compiler gives you shit for it. Like, but as you can see, the compiler messages are beautiful. They tell you where you fucked up, how you fucked up, and how to unfuck yourself. All in one really convenient package. Like it says like, okay, this is line 8, this is where it went wrong, and some record fields undefined. Venue, you need to define venues. Like, oh wow, man, thanks. I was going to just start passing undefined around, and that could cause serious problems later in some sort of terrible runtime bug that we spent hours debugging. Yeah, cool. But we still have this problem that we want the venue to be optional, right? Maybe we just don't know yet. So what do we do? Well, maybe you look inside. Oh, yeah, actually, I forgot about this. Also, if you put in extra things in JavaScript, we go like, I don't know, man, I don't need this extra bit, but I can fill out the function fine, so whatever. Here, it gives you a lot more grief, and it makes you be explicit about what you do, and this is going to be very useful later. So even if you put in extra things like, man, this doesn't look like a type I recognize. Okay, so you read the documentation about this thing called option, which lets you have like some of a or a none. And you can think like, is this kind of like nullable? Maybe. So I can just pass that in, right? And then I can have undefines and type and like strings all the time, right? But no, you can see that on the venue, it still gives you this underline now. It's like, what? I pass you a string and everything. This should work. But no, no, no. It expects an option string. And this means like it's a type that is either some or none. So when you get to the venue, just give it some. It's like, yeah, but how did you resolve this? So we can do stuff, we can get into this a bit more later, but we have this thing called pattern matching, right? So we put in the venue that we get back, and we have this switch statement. And if you have some of something, give me back the venue that you actually got. And if you have nothing, here's a default value. Now, you can do this by doing like undefined and null checks all over your code. The difference here is that you can't just pass undefined or null around at all. You get rid of, the compiler will catch you every time, which means you get rid of a whole category of bugs of undefined and null in your application. That can be very, very insidious to solve, right? This is amazing, because this is like, I think something like 30% of JavaScript errors are due to undefined or null being misused or passed in some way, and here you're caught every single time. Like, Reasonable can't make you write fantastic code, but it can make sure that you don't leave any holes. So what kind of stuff does this solve that isn't solved by Flow or TypeScript? I'm going to steal an example from Patrick Stapfer, who's RYYPPY on Twitter, because he likes difficult Twitter handles. He's a really cool guy. You should follow him. He's also very handsome. So we're going to model tic-tac-toe, and we're going to do it in Flow. So we're going to have this token type, so we have a square and tic-tac-toe. It can be an X, O, or an empty, which is great. And a board, you can see like we define sort of like a stringy num, yeah, so not really a type, but like we're trying to match some strings, I guess. A border is an array of tokens. A player can either put down an X or an O, and the progress, each tick of the game is like, you can either take a turn and play for some thing. You can have a win condition when you go 3 in a row, and the player will win, or you can draw, in which case you don't need to put a player because both players are in a similar state of draw. And the board state would be something like this, right? So we have board and progress together in the state. If you write this naively in JavaScript with types, you might do something like this. So you define your progress to be like, okay, we're going to do a turn rather than a win or a draw, and we're going to do it in player X. And then we do a switch statement. Then we go and run through all the cases. But there's a few things wrong here that Flow will have a really hard time catching. One, switch is not an expression, so you have to do all these awkward returns, and you don't have you have to worry about fall through. There's no exhaustive check, so there's no draw condition here, and it won't whinge about that. And you can also see that if you're very eagle-eyed, the case win is wrong. We're looking for win. And because we're just matching random strings, like this is very, very, very difficult to type check. It's not real typing. We're just doing something that imitates it fairly well, but nowhere near good enough, right? If we were to do this again in Reason, we're going to use these things called variants with tags. So the X and empty aren't strings. They're these conceptual things that can hold other types, right? They're really cool and very worth reading at one page on the Reasonable documentation just for the concept of them, because they kind of make everything else a lot easier. And then we do the same thing. A row is a bunch of tokens, a board is a bunch of rows, players can be X and O, and a progress is like a tag that holds a player, a win that holds a player, turn tag that holds a player, a win tag that holds a player, and or the draw condition. And then we have a similar state with some shorthand. And then this is our actual game logic, which you can see is immensely cleaner. And our typing on the progress is so clear that it actually defines what a bit of progress easily is. So you have a timer player, win player, or a draw, and it's very, very easy to read this. And then we have to switch this this pattern matching on the variants themselves about turn player, win player, or draw, and it's basically matching on the structure of the data rather than on values like strings, which makes it way more powerful, because it'll only match on a turn with a player, or win with a player, or a draw. If we didn't have the draw, we get a compiler error saying, hey, this isn't exhaustive, you forgot about draw. Or if you just have a turn without a player, you go like, man, you need a player attached to this, like this is not exhaustive, right? And you can do some really, really clever stuff with this. You can match in all kinds of shapes of data, like an array with a certain number of elements, for example. And you can put like guard clauses and when statements and all that kind of stuff that makes logic much, much more expressive than you can do in regular JavaScript. So, you know, I guess having really safe code is fine, and not having nulls is fine, and writing concise code is fine. But I promised you a lot more on that large bullet pointed list. And that mostly comes from our good friend, BogusTip. So BogusTip is an amazing piece of software that leverages the 100% type soundness that reason_nl gives you to do some really impressive stuff. So, for example, did you know BogusTip compiles 10 times faster than TypeScript, right? That's pretty quick, and that's really much faster than Babel. Like I've overseen like projects with like 50,000 just tests, and watching the setup time on Babel, like, come on man, it's time to go, let's get lunch. It can be a very long time. And here's a little tweet that shows some examples, and you see like the OCaml compiler is an order of magnitude quicker than the next closest thing, right? So let's compare two pieces of code. On the left, we have a bit of immutable code that does a simple bunch of operations number of time. On the right, we have the same thing in OCaml. So with these types, you might expect the performance to be better, right? And that's about right. So the OCaml version is 3 times faster due to a number of reasons. And it's like, okay, that's pretty cool. And things of Elm have shown that through having pure types, we can do great things with performance. But the problem is the bundle size is always larger. However, if you compare the file size output from these two pieces of code, we can see that the BogusTip version is significantly smaller to achieve the same thing. You can ooh and ah now about this amazing fucking achievement, right? Right, okay. You have questions. How does it achieve these amazing numbers? And it's a complex question that is all on the BogusTip wiki, and it's really cool to read through. I'm not a computer science person, but even I thought like, oh, this is kind of neat. So just as a very quick thing, like for performance, it recompiles some expressions, which is much easier with pure functions. The variants we talk about with the tags, they actually have a O1 branching because they can be turned to a tree. And doing index lookups instead of key lookups makes for much better performance. File size-wise, there's so much dead code elimination, it's not funny. There's really clever linking of bundlers, and it leverages some really cool stuff inside OCaml to do so, right? So we don't really need to care about that. We just know that it gives us really cool stuff. But there's more. It can also give us human-readable output, which is very useful if you ever want an escape hatch to go back to the regular world of JavaScript, right? And I don't think there's any other performant transpiler compiler that does this, and we're going to play a game to prove this to ourselves. I'm going to show you two pieces of code, and I want you to tell me which one was done by a compiler and which one was done by a human. So, number one, was this made by a human? Or, number two, was this made by a human? Hands up for number one. Hands up for number two. Surprisingly equal. Okay, well, it was a trick question. They were both made by the compiler. But the fact that there was a split shows it's pretty good. So I stole this joke entirely from a guy called Sean Grove. Thanks, Sean. He is also incredibly handsome. Look at that picture. And he can be followed on Twitter for more really cool reason stuff. Yeah, just that hair though, right? Anyway. I think the thing that BogusTip really offers more over any other platform in this sort of space is interop. So interop is the grim, harsh truth that takes all these cool pieces of tech and makes them hard to use and pragmatic projects. So with all these technologies, you know, trying to leverage the NPM ecosystem that we rely on, or using dirty APIs is very difficult. Like Elm, I love Elm as a concept, and Evan is a great guy, but God damn, is it hard to do certain things, right? And this is where BogusTip really excels. It has this foreign function interface which is completely crisp. It lets you go both ways between the JavaScript and the reason world while still maintaining type safety in a way that isn't going to kill you. And we're going to demonstrate this now. So let's say you want to use some JavaScript and reason, right? And what we leverage here is the external keyword, right? External basically means like go outside and get something back, right? And what we have to do is make a very shallow type definition for it. So here we're saying, okay, we want a value of pi, right? And it's going to be a float. And we know on the global object, there's this math module when we run it in the browser, right? We want math.pi, and we told BogusTip, like, it's going to be a value, right? Just go get it for us, will you? And it's going to be a float. And then we make a little function that defines like how to calculate the circumference, right? And it takes an argument pi and an argument radius. And then we like want to calculate some circumference, so we got like 2 times pi, 2 pi r basically, right? Area radius. And then when we call it on, we actually call the function assigned to a variable called piece of circumference. We pass in the value of pi we got from external and diameter or the radius of the pizza. I think this is like an 18-inch pizza technically converted to meters. I don't know. I was hungry at the time when I wrote this demo. Oh, by the way, I'm going to sneak this one in here. Did you know that ReasonML lets you have labeled arguments? So here we're going to say like a label of pi and a label of radius is going to be passed into this function. And then we can actually, when we call the function, we can change the order of the variables and just say like, okay, radius is going to be blah and pi is going to be blah. This is really cool because how many times have you seen a function with like function name, open brackets, like, like 3719 false and a string yes, and you're like, I have no idea what's going on here. How does this map onto anything? And you have to go look at the actual function, blah, blah, blah. Like, named arguments are great. Like, I miss them so much from other languages, and it's just convenient to have them back. Yeah. But we want to not just like pick random values from the DOM, right? We want to import npm modules. So let's just make a little function, this add function in JavaScript, right? And we're going to export it. We take an x and y, add them together, right? Now we want to import that into our reason. So we say, okay, our external add is going to take 2 ints and give us back an int. It's going to be called add, and the BS module is going to be at this location, right? And then we create a variable called 2 and 2 added, where we add 2 and 2, and then we just log that bad boy out using our old friend JS log we described earlier, and as you can see in the node, we get 4 out. So we just imported our our JS module into our reason app and use it straight away without any fucking fuss, while still maintaining type safety and all the performance benefits, which is really cool, right? Hey, easy. Now you might be wondering, wait, haven't I already defined types of things? Don't all my libraries have like TypeScript definitions and flow definitions and stuff already? Do I have to write another set of types for importing all these things from my npm packages? The answer is no. Because with things like reasonably typed, you can actually just take your existing type definitions from Flow or TypeScript, and it will retype them for you into Reason. So you can use those packages type safer today without you having to write a single piece of code. Yeah, laziness. I'm a very, like, all the best programmers are lazy, right? Go on. Okay, how about the other way around, right? We want to use Reason code in our JavaScript. Well, if you remember back at the beginning example, we made this little function that just added some numbers together, and we sort of had an export, right? So we can actually just call this as a normal piece of JavaScript from the library folder. And, you know, here's like a bit of adding in Reason. Yeah, this makes this thing. Oh, broke slide. Sorry, guys. Right. And, you know, inside a JavaScript, we can then just require this output JavaScript from the BogusScript and run it, which is fine. So I guess, and then what we can do, like, because we have JavaScript, the old JavaScript and the BogusScript JavaScript, we can just use our old friend Webpack to pull them all together into the same bundle. I mean, that's fine. And then you could base it, your npm code would essentially be like, all right, we're going to say BogusScript, make all the JavaScript first, then get Webpack to bundle our existing JavaScript and our BogusScript JavaScript together, right? But that sounds like effort. I mean, it's like 3 lines more than we'd have to write, right? So there's plugins, of course. There's a BogusScript plugin that'll do this for you, or even a BS Loader plugin that'll do this for you for Webpack. So actually, you can now just straight up import your reason files directly in your JavaScript without having to go to the output folder or anything like that. Just go, here's my reason file. When you bundle it up or when you compile it, just make sure you run BogusScript for me first, and I don't have to think about it whatsoever. And that's really cool, right? But I hear this is some sort of React conference, so I should probably talk about some React, right? Let's build some React. Because now I've kind of sold you, hopefully, a little bit on the virtues of Reason as a platform. We're going to try making some React with it. Much like Create React App, there's a Create Reason React App, which you can see here, and it does the normal stuff where it gives you a little skeleton application with the same kind of commands you might be used to. And it comes with like lots of stuff you might expect. So we have like a scripts folder like you do in Create React App. And we have stuff like, you know, hot reloading built in, we have jest built in, we have, you know, an example bunch of applications built in, and it's all ready to go. So you can see in our dev dependencies now we have Reason React and we have BogusScript jest, which is essentially just some bindings to go and use jest, right? Our BS config is now a bit more complicated, but not by much. We still have the super arrows on. We have JSX because Reason supports JSX natively. Cool. We have reason React as a dependency and jest. And we still go in the sources folder to actually do our stuff. So this is what a this is what the index file looks like, right? So this is still in this is in reason, and we're just basically saying like, oh, do the service worker thing that comes with React, create React app now to do PWA stuff, and we're going to do our like normal like React DOM render element stuff, saying, hey, put this component here on this piece of HTML ID called root. Cool. So what does our application actually look like? What does a reason component look like? And this is it, right? So we do a bit of magic at the top here. We say like, hey, BS raw, which basically means run raw JavaScript, do a require for CSS, because we don't really care about the CSS here. We care about the application logic. And then we define what a component is, and we kind of pick the component beforehand. So here we say like a component is going to be a stateless component, right? And we're going to call it app. And then our component itself is actually just the spreading of the component object, and then any other functions we want to override. So it's very much like everything being a pure function inside your React component that you might be used to writing. So nothing hopefully too scary here. We have a prop called message, and we have a render function, as we used to. Then we have a function that basically just returns us the JSX that we expect. This underscore self thing here just basically means like we don't plan to use self, don't worry about the compiler. And same with the underscore children at the end, which says like, hey, you know, we can have children passed to us, we don't have any right now, so don't worry about it. And then, yeah, we write our JSX. The one thing that looks a bit icky, which you may have noticed, is that when we want to write text into our divs or other elements, we have this reason React string to element bit. Basically because you want to actually convert a string into like a HTML element, and because those aren't actually the same exact types, you have to run a conversion process. We'll write a quick shorthand for that later, but you know, for the example, obviously it gives you a very verbose interpretation. Okay, and this is what it looks like. Like it's a website that runs, you know, hooray! Like it's it's great. It uses reason. It outputs. It has a cool more red logo. What else do you need? Okay, so let's try and make some changes, right? So one, this like reason React string to element thing is very verbose. Let's get rid of that. So we start to write this SE shorthand. So it's a function called SE. It takes some content and it brings us the element out. So as we begin to write it, we can see that we have this really cool editor integration that tells you exactly what you mean to do, right? So you spend most of your time hitting tab rather than writing code, which is really, really nice. And let's make a much simpler application that we are in charge of, right? So let's say we have a component that's just going to have one header tag, and it's just going to say like hello React Boston, right? And we use our SE thing from earlier, so we can just pass in the string into the SE and to get the content out, or get the element out. Okay, cool. This is much nicer, and we haven't used the message prop. Hey, sweet, it works. Okay, cool. That's fun. Yeah, that's fun. But you know, we're good engineers, right? So we actually want to test our components, right? We want to write a test first, ideally. I don't know how many people actually do this, but we all want to, right? So you know, we run like, we sort of had like a test thing inside the package.json. So we run like yarn test, and hey, the test passes. Then it's kind of suspicious because we changed a lot of stuff in our component. The test shouldn't pass, right? And then we look at the example test, like, oh, right, you just add some numbers together and it's completely separate from, from the actual components. Like, okay, fine. So when I write tests for React components, I use enzyme, right? And we can see that we had just installed, but not enzyme. And we kind of worry, like, wait, is enzyme even supported yet? Has not anyone made bindings? And the answer is, of course, someone has. Someone's made BogusTip bindings. So we can use BogusTip today. And we will, because we want to write a test. So we add BS enzyme into our BS dependencies, and we just do we add it to our project as well through npm. Like easy peasy, right? And yeah, let's just write a test with enzyme. So this open stuff is to do with modules. It's very much like in reason files are modules, so you don't have to do those by hands, and you basically pass modules around. So files are first-class functions as arguments as well, which can make some really interesting patterns. You don't have to think about it too much, just that like you don't have to do like the export default at the end. You already exported, right? So we open Jest. That gives us access to all the Jest functionality inside this module. And then inside the describe, we say we want to test the app component, and we want to test that it renders a message that we pass in. We open the expect, which is just like part of the enzyme module that we want. inside that block scope. So we say, okay, the test is going to be, we test that our component renders a message, right? And we have a title called hello test, and then we just do a normal thing where we call and we pass it the shape of the component that we want to test, right? And we pass in the title into the message prop. And then we expect the text of the component to be reasons overrated. And as you can see, this fails because reason is not overrated. So this render, so you can see like we got a normal test message at the bottom, right? It's like, hey, this is the value we expected, and this is the value we actually got. Because we passed in hello test, but we put the wrong 2b in, right? So we change it to hello test, and our test passes. Hooray, we have a failing test and a passing test, and we now have the same test workflow that many of us have for our components already. We can also clean up a bit, because we realized that, wait, our prop was called message, and we did call it title, so let's clean it up and call it message, and we can just pass in the message straight away. Now, in regular JSX and JavaScript, if you just pass in the prop, it turns into a Boolean. You have to you often have to do the pattern where like message equals message. But because again we're not using any sort of weird type system or coercion, we can just use punning to say like, yeah, message here is the message that I want you to put in. I don't want you to say like message is true in the prop space. So that's convenient. Yeah. So we have this content. We have everything working. And you know, like, hey, great, we have a clean little stateless application, right? But we want to be, sometimes you need to have state in our application. And for this, we're going to use reducer component. So there are several kinds of components. There's stateless ones we saw initially, there's stateful ones, and now these more recent ones are called reducer components. And these are really cool because they leverage parts of the language that, like pattern matching, to handle state in a way that's very, very similar to Redux. But because we already have these tools available at the surface level, we can start using them directly in our components. So first we say, okay, we're going to have a reducer component. And then the compiler goes like, okay, man, like you can say it's a reducer component, but we're missing stuff. Like we need to have like, you know, initial state. We need to have like, you know, an action and stuff. Like, okay, fair enough, compiler. You've got my back. So, okay. Let's think about what we want. We want to have a page with two buttons. One we can click hello, and it gives you like a hello message. One we click goodbye, and it gives you like a goodbye message. Okay. So two kind of actions we define are greeting and farewell, right? In our variant tag system, and we put a little bit of initial state as well, where we say like, okay, the text is going to be hello Boston to begin with, and we have to define the shape of that state as well, which we do above, right? And because of the type inference, it knows that up there the state means to down there the state. Okay, great. But then we actually want to, you know, make stuff happen. So normally, I guess what you do in a component is you do a bit of like set state, and that's okay. But because that's kind of like just mutating wildly and hoping for the best. Here we have our switches from earlier, and we can do on when a certain tag is put in, we go, okay, we're going to update this component with this particular state shape, and that's all fun and games. And if you click on one of those things, it'll now like run through the thing. And here you can see the underlining because again, it's not exhaustive. We want to do the farewell as well. I think I might be missing a slide. That's unfortunate. But essentially, on the button, we then just say like, oh, on click, we do reduce with the particular tag that we want. So here we can see that we're actually using a very, very clean version of the entire Redux system to control our applications. Rather than having to do a really bad imitation through actions and reducers and all the other tools that we use to try and get something that is akin to pattern matching for our state management. So, okay, that's great. If you have a new application, you can do all this fancy stuff, but what about legacy? Well, I made a simple application to show that we can actually start integrating reason into our existing JavaScript React stuff without a problem, right? So this is a very simple application. I put it together like from scratch. So it just has Babel for JSX. It has Webpack to bundle stuff together, normal like React DOM stuff, right? And it's very, very easy. You've got the normal hello world. I just assign it to some ID of root, and it's like as simple as it could possibly be. Like it says hello world, right? And let's quickly make a stateless component that'll try and output BAM, because why not, right? But we also want this to be ingestible as a component by normal JavaScript React. So we make the same thing. We have a little message saying BAM. We put it inside p tags, no problem. And then we use this thing called wrap reason for JS on the default, pass in the component, and at the end there it's like, oh, we're just passing in no props and children, don't worry about it. Okay, great. And because we put it on default, and because remember modules are already like modules are self-exporting, the default here will compile defer to the same kind of default stuff you expect in a JavaScript module. And then how do you pack this all together without having to do lots of manual work? Well, you just use a thing called BS loader, just go in and scrape up your reason files and let you work harmoniously with your stuff, right? So if we go inside our old render function for the JavaScript component, we have hello world, and now we use the BAM component that we already defined in Reason seamlessly, and it magically works. Like, it was just a standard default import from a Reason file where we define our components in Reason. So yeah, okay, cool, man, that's a great thing. But we want to go the other way as well, right? We want to be able to import JavaScript components into our Reason components and put them back into our JavaScript components at the end. Well, yeah, because we have all different kinds of, like, otherwise you're going to get pain points eventually in our project where you have to make sacrifices of the functionality we want to create because the platform doesn't support certain actions. We don't want to be in that state. So here's a normal stateless function, right? We just return some divs, we export it. Then we make this quick little wrapper saying, like, okay, we're going to define this external, and it's going to be of type of like a React class from this file. We have the normal make, which Reason uses to think about components as a function because it's just a default name. And we have this convenience function called wrap JavaScript for Reason, and we say it's going to have no props. This is a bit of an ugly syntax. They're going to clarify it in the next version of Reason, but basically saying, like, yeah, no, it's going to be an empty JavaScript object. And we're going to pass in WAM as a React class that we want to wrap. So now, inside our Reason component, the original BAM one, we import the wrapped JavaScript WAM into our Reason BAM, and then wrap both of those with our previous code into another JavaScript function, into the BAM JavaScript, and then find, just updating that makes the other thing work because we just put a JavaScript component into our Reason component, which we put back into our JavaScript top layer app. Hooray! So we can do it on every level. Fantastic. So, okay, what this really shows is that we have the ability to write really exceptional code with lots of type safe that's very, very performant that we can integrate into our tool chain today. And the tools exist within React especially to make this very convenient and also give you the ability to use them back and forth without much pain. We can use our external tools and everything that we're used to. And what this does, it really destroys all of these bits and pieces that we need to always worry about. Like, we don't need Flow anymore for better typing. We don't need Babel because BogusTip is there. ESLint is basically irrelevant. And Prettier is not important because Prettier is based off Reason format, right? That comes pre-built and has fewer options, so we have fewer things to argue about. And we also have these fantastic language features, right, that are really, really powerful. And I've only explored very, very few of them. And you do have to read about them a little bit to really appreciate the things that it can offer you in functionality and safety and, sleeping at nightness. And to give you an example of, like, what you can achieve with Reason, let's look at Messenger.com, which is, the Facebook platform for the online web version of the Messenger chat, right? Very, very popular. Loads of users, big code base. And they migrated half of it to Reason recently. And now they've got sub 100 millisecond build times. They've got 10 bugs a year, and they used to have them daily. And they've gone from the average refactor time for complex components from days to minutes, right? That's incredible, right? This, if you have a complex application, this is what I can give you. Like, I don't know about you, but I've been on call for stuff. There's been things that just explode all the time. And having the ability to just, like, even the build time is much better because you can have a much better feedback loop when you're developing. There's nothing worse than pausing and being broken out of flow, right? And having this sort of certainty about the goodness of your code is unparalleled when you're shipping things that matter. There is one more thing that I'm not really going to go into, but because I've got 6 minutes and 10 seconds left. But one of the coolest things about Reason that I haven't covered here, because this is a React conference, is that it can compile natively to basically anything. You can take the same code for your Reason application, you can compile it straight to the CPU. Any CPU, really, because OCaml has so many compile targets. Straight to your server, fine. You want to write native React Native code in Reason that turns into JavaScript, fine. But you can also write React Native code compiled to native and run directly on your phone. Like, this is, a way of having really, really, really good performance benefits. You can run an ARM, you can do all kinds of stuff. And there's this other thing, which is called unikernels, which I'm going to very briefly hype, because when you write an application, when you're very proud of it, you're going to put it on the server somewhere, right? And that server is going to have an operating system that runs the application. Because you don't know about networking stacks or whatever. You just want to, like, serve cat pictures. So, but you have this whole operating system underneath you. And you think, like, okay, with Docker containers and stuff like that, you can say, okay, we share the operating system, so it's a bit better. But, like, there's so much the operating system you don't use. It's a huge attack surface. It's so heavy. what unikernels do is it lets you write your application OCaml and then like just take pieces of OCaml like the TCP/IP stack and put them into your application. And then your application doesn't need an operating system if it's just made up of OCaml components. And you take that directly and put it in the hypervisor without an operating system entirely, which means you can do stuff like sub 50 millisecond boot times for a unikernel, like, and this is the whole shebang, including the operating system. Like, it can be 100 kilobyte, 10 megabyte in size. You can have 10,000 instances on one server, and you can check each unikernel instance into Git, so you know exactly what's running on your production machines at all times. And that's really insane. So if some of you are into DevOps like unikernels, man, it's gonna be crazy. So, should you use Reason now? I've been given various versions of these talks for a couple of months now, and I always said no, but I'm starting to say yes. There are still problems, right? The community is very mature, stuff changes all the time. A lot of the documentation is getting a lot better, but a lot of the time you do still have to go to the Discord chat. By the way, the Discord chat is next level cool. Like, everyone's super friendly, you get replies very quickly, and you know, it's great, but there are times of frustration. There is a small ecosystem, so sometimes you do wonder how to get stuff, and you read 2 blog posts and you're like, okay, but which one's better? So when you're starting out, it can be quite difficult. And it is a new community, right? So there are fewer examples than there might be. So there will require some upfront cost in getting used to it and understanding the syntax, unless you're already very familiar. So there have been times, especially in the earlier months, which led to great frustration. You know, I've been driven almost completely mad by trying to write Reason in difficult circumstances, so much so that the pictures turn 90 degrees, or I just like end up clutching a bottle of whiskey in some dark basement lair somewhere, attempting to keep my sanity together. But it has gotten so much better, to the point there's actually a very, very usable platform that I am shipping into production, right? And it has made my life significantly better. It's also worth remembering that React was originally written in SML and then converted to JavaScript. So many of these philosophical things you've learned through writing React are very applicable to writing Reason. And there's one final point that I think is very important to think about. With React Fiber coming along, we are going to have all kinds of compile targets, which is really cool, right? All these renderers. And JavaScript is starting to become a staple of software in all kinds of devices. We used to just worry about making buttons, you know, that click with fancy effects and things vertically aligning correctly on a web page. But JavaScript's starting to run on things like medical devices and plain hardware. And I think it's up to us as a community of engineers to take software development a bit more seriously. We have to really be concerned that our code will run well. And we have to, as a community of engineers, really accept that the responsibility of these devices and this external world that we create is in our hands. And if we can use things like ReasonML to give us more assurances in the goodness of the things we ship, I think that's important enough as is. Okay, my name has been Marcel Kutz. Thank you for listening. I hope you all try Reason.
Speaking of running JavaScript on hardware, there's a drone later today, I hear, but we'll see about that. Okay, we got some time for questions. You want to do a quick Q&A?
Young man.
Those orange annotations you were getting, is that like a VS Code extension?
Yeah. It's a VS Code extension called code links. So it automatically does them for you. Oh, sure. So the question was the orange highlights on top of the functions and types inside the editor. Is that a VS Code extension? The answer is yes, and automatically makes them float over all your stuff. So that's cool. It's very helpful when you're reading your own code or other people's code. Man in a white shirt.
So if you're targeting client side with this,
Mm-hmm.
you still support code splitting and like multiple buckets.
So we can use all the same techniques. The question was, do we still support code splitting when we target the client? Well, like we said before, we can still use the same tools and processes that we have now. So you can output the JavaScript and then run it through your regular Webpack code splitting or your next code splitting like you're used to. So for you can choose exactly what level of involvement in the toolchain you want to have, right? And that's a really good thing about it. It's very flexible in that way. Because it does just output good JavaScript that you can then put into your regular process that you're used to and has good value for you and your team. So no, great shot.
I assume that prop types are time safe and enforced at the call sets.
Yes, so prop type safety, yes, absolutely safe. Yeah, they're very strict about these things. So things like spreading carelessly will be called by the compiler. Oh, and I will say the compiler errors are integrated with reason React as well. So if you do your reason wrong, it'll also catch that in a very helpful way. It'll guide you to making good components.
Let's take one more question.
Oh, I might get away with it. Oh, wait. Oh, there, chap in the corner. Is there an OCaml interrupt story? So if you're writing reason code, you already have OCaml interrupt, because it is OCaml. It's just a different way, syntax of writing OCaml onto the same compile layer. So you can write it. There's even like I have a plugin on my browser where I can just paste in reason code and turns on OCaml, or vice versa. There's also plugins for Chrome that lets you look at like the OCaml documentation. It just tweaks all the syntax to be reason.
So stuff from like
Yeah. All the Danish stuff is readily available. Yeah, and they're really into this stuff as well. They seem to be having great returns.
All right, thank you, Marcel. So we're going to set up Ken here, do one 30-minute talk, and then break for lunch.
Oh yeah.
Okay, great job.
Thanks, dude.
No, get the thing going. I mean, it is what it is. Get right in there. Okay, make sure we're all set here. Good, babe. Yeah.
Yo, Kenny, can I stop you for a minute? No.
Yo, what's up, bro?
Passport.
Nice.
Are we good on the audio? Okay.
Yeah. You guys right? Let me just check my shit real quick. See here. How are we looking? Looking good. Okay, yeah, we're good.
Don't test the audio.
I mean, yeah, I think it'll be all right.
All right. We're going to get going. Here we go. Ken, take it away.
All right. Hey, what's up, Boston? All right. So my name's Ken Wheeler. I'm Ken_Wheeler on Twitter. If you guys want to throw a follow my way, I'll wait. You want to read a bunch of trash? And I work at a company called Formidable. It's a Seattle-based consultancy, but I work from New Jersey, where they do a lot of really fun JavaScript stuff. Drove up here, which is a hoot. And I came here to talk about context in React. React context, not like this context or anything like that. I'm curious, how many people have heard of context in React? Can I see a show of hands? How many people have used context in React directly? Okay. Yeah, so this should be fun because context is dope, and we're going to learn all about it. All right, so context is a previously hidden, sort of unsupported React feature. Up until recently, there were no docs about it at all. It was kind of just in the code, and some libraries used it, but you know, there was maybe like one tutorial on using it. But it's used everywhere. If you're writing React code, chances, I mean, almost 100% chance that you're indirectly using context in some way, shape, or form. It's an extraordinarily powerful feature that can also ruin your day, which is why probably it was undocumented for a while. All right. So what the actual deal with context is that so React applications are tree structures. You have all your tags. It's a lot like the DOM, where it's a tree structure, right? You have your root node. You have branch nodes and leaves on the end. So once in a while, you want to get something from point A to point B, right? Point A being the root or wherever, and point B being a deeply nested child node. Right? So if you wanted to do that with props, right, you would have to pass the props all the way down. Here we have your component. You're saying my prop equals this prop. You'd have to do that a bunch of times. Or if you're a terrible person and you don't want anybody to be able to work on your code, you can use spread props and not even identify them. But passing props all the way down is super lame. Nobody wants to do that. I mean, you could do it for like a level or two, but at some point, you're like, this is ridiculous, right? So what context lets you do is take your data and essentially teleport it around the tree. Most of the time downwards, but I'll get into other stuff later. So now it's more like this, where you're just taking it from the top level, passing it off to Scotty, and here it reemerges in B magically. So what is the catch? This next slide, this is bullshit, okay? So this was going to be a funny slide, and you'll see why, right? But then they ruined my joke. I was like, you serious? So, yeah, the actual catch is, right, it's been historically categorized as an unstable feature. This is right from the React docs now that is documented. They say the vast majority of applications do not need to use context. If you want your application to be stable, don't use context. It's an experimental API and it's likely to break in future releases of React. Bullshit. No, I mean, it kind of is, right? But, that's a little bit of a stern warning for something that, if you weren't, okay, buy Redux, buy React Router. All these, everything you can imagine, React Router, Redux, MobX, styled components, every single one of these uses context, right? And, it's not like cute, like by choice, right? It's because you have to. Right? If React didn't have context, I would not even use it. I wouldn't use React because it's a necessary escape hatch for doing certain things. Right? So you say don't use it, but yeah, you should use it. It's awesome. Just use it right. Right. So when would you need to use it? Right? The big homie Dan Abramoff. I know it's Abramoff. I say Abramoff anyway. Deal with it. He put together this little graphic. I don't know if you could see it that well, but he's got this adorable function that says, should I use context feature? Right? So the first one says, am I a library author, or do I need to pass something down deeply? And then inside of that conditional, you return, am I fine with API changes and buggy updates? If it doesn't go into that, you say, is my use case theming or localization? And then you return, I promise to use a higher order component instead of using it directly. All valid, right? The last one is library asks me to use context, which a library shouldn't ask you to directly use context. So he throws an error there. And the last one, he returns YOLO, which is kind of my shit. So, I mean, it's not going to discourage me. Realistically, anytime you want to reach deeply into the tree is another one. Reaching deeply out of the tree, finding things in the tree, or communicating across branches. These are, because it's a tree structure and you're kind of just passing things all the way down, it's not always easy. You'll come across problems where you're like, wow, okay, like this pattern has worked up until this point, but how am I going to make this work? Context, that's how. Right? So, if you haven't used context, we're going to find out how this works, and we're going to be badasses and find out. Right? So there's three cornerstones of context. Right? You have context types, which is much like prop types. You have child context types, which is the same sort of thing, and you have get child context, which is how you actually pass it down. Right? So say you have a root component here. This is using super fancy Babel script, but you can do it right on the element too. You could say root.childContextTypes. But anytime you want to pass context down, you have to define it much like prop types. So you're going to say, message prop type strings. You're identifying what it is, right? And then get child context is how you actually provide what is going to be passed down in the context. Here, I'm passing down unfortunate truths. Now, that's going to make it all the way down to the child element. Now, if you're in your child element, right, and you want to render a message which is undoubtedly true, you can define context types on it, right? So in the parent, you define child context types. In your deeply nested child, I call it 4 levels deep component. It could be 283 levels deep. It doesn't matter. You define context types. I say, you do the same type, right? If it's a string up top, it's going to be a string on the bottom. And then you can access it on this.context, much like you could access it with this.props, right? So here's an example of like a stateless functional where you would go and you say 4 levels deep component dot context types equals, right? And then you can do it like that if you're not using a class. Context is the second argument in the function. Right? So it's only available via explicit request. You can't just put it at the top and send it down and expect things to have it. If you have a child that wants a parent context, you have to define it. Otherwise, it's not going to be there. Context is going to be empty. Right? So the behavior of context, so you might say like, hey, why don't I just use a global on the window? Yeah, because we're professionals. No, realistically though, so it can be updated, which is kind of cool, right? So right now, okay, this is like cool shit, but it's also shit that's going to change. So we're going to get to that, but it can be updated. So if you update something in the parent context, generally speaking, right, it'll force render all the way down. So like if you have like a color up top and you change it from blue to red. Generally speaking, down here in your component that gets context, it's going to change, right? So if you have internationalization and you change from like English to French or something like that, that'll happen, right? Another cool thing about it that I do a lot of is you can modify it on the way down. So context isn't a thing that's going to, so if you have a child that intercepts a context from up here, you can take that, modify it, and then pass it down to its children modified. Which is very helpful for a demo that I'm going to show later. Right? So let's look at some context updates. How is this font size looking? Yeah? Yeah, let's bump that up. How are we looking now? You see this? All right, so I have an app component, right? In Code Sandbox, which is the jam, if you didn't know. So I'm defining a color as a child context type. I have a state, and then I get child context where I return this state to color, right? So in here, then I have a component called theme text, and I have a button. On click, we're going to toggle. Toggle sets it from blue to red and back again. So now let's go down and look in our themed text here. So in themes text, this is a stateless functional setup. You have context here. I say that this h1, the color is going to be context.color. Head on back to our index, right? Everybody clear on how this all is working? So if you change it with set state, like that, it's going to change. Right? So if you have a theme and you change your theme and you're passing like blue to everything and it's like the primary color of your theme, generally speaking, it will change. Right? All right. So, you probably shouldn't do that. And I'll tell you why. Right? So number one, the API is going to change. After speaking with Dan Abramoff, I was like, listen, I'm gonna give this talk on context, and like I know, like you say, like don't use context and everything like that, but I'm gonna tell them to use context. So let's be like kind of clear on what's gonna happen with context and all that. So it's gonna change, and what's probably gonna happen is that they're gonna turn off updates, right? So when you update that context, it's not gonna re-render the tree. So now you'll have to handle that. Now, until they do that, there's a lot of libraries that use that. I mean, like React Router actually uses that change. Like when the history changes and that changes, that's actually what triggers your new route, right? Because it's switching off of context. So I use it. I mean, this entire presentation is written in my own presentation library, which is in React and uses context for routing. It uses context, directly for routing and theming and everything like that. So when the time comes, I'm happy to update it, but. Another thing that's funny is that your updates can be blocked. And I will show you what that means, right? So, back again, we have our cool demo. So cool. Couldn't even be bothered to style the button. Such a fuck up. So we have this here, right? We have our, pretty much the same thing before, but we're taking our theme text and we're wrapping it in a blocker component. So what this blocker component does is should component up. Wow, did I really just mix those two? All right. Well, yeah. This is double secret sure that it's not going to update, but you have pure component and true component update false. Whatever. But yeah, if one of the interstitial components doesn't update, your context isn't going to make it there. Right? I hit toggle. Even though context is in our theme text component, because that blocker's there, this isn't going to update. Now, this example, you probably look at me and you're like, "What, are you serious?" But actually, what the real world where you're seeing this happen is hilariously enough with Redux. So Redux Connect implements like a pretty serious should component update in there for optimization. And one of the problems that you see with it is with React Router, because React Router depends on that change, and Redux can block that change. So there's like a billion issues on it, and they even created a library called React Broadcast to help that, right? To help circumvent Redux. So Redux actually blocks context updates deeply in certain instances, particularly with Router. So that's where you'd see this, not this, extraordinarily visible wrong way to do things. So I'm going to show you how to use it safely. Right? If we take a look here, what the solution to this is, and if they do change context moving forward, what we're going to have to do is a subscription model. Right? So generally speaking, if you want to use context safely, and you see this in a couple libraries, I know Styled Components Provider does it like this, to kind of jump the gun on that. But the whole idea really is to just whatever you're passing down, just pass it down the one time. You take an object and you pass it down, and then everything else that's changing, you do that as keys in the object. You do subscriptions, right? So here we have the same thing, and magically it works again, right? Even though we have the blocker. So the way that works is, rather than passing the context directly up here, I create a theme provider. If you used Redux, you've probably seen provider, or MobX, you've seen provider. You use Style Components, you've seen theme provider. So this theme provider passes your context down. You have child context types, theme, prop types, object. But it's a little bit different. Now we pass down a theme object, right, instead of just color. And what it has on it is a subscribe function and a get color function, right? So what our subscribe function actually does here is, in our constructor, we're creating an array of subscriptions, and we set our color here. So when a new prop comes down, then we can get, just set this.color. So the component will receive props, this.color is next prop's color. And then we're going to call our subscriptions to notify them that it's time to update. So then down here, in component did mount on our theme text, realistically, this should probably be abstracted as well. So when you're doing context, you want to abstract it into providers and subscriber, like higher order component kind of stuff, just because you don't want to have to change it in a billion places when it does change, or if it does change. But yeah, you subscribe here, you subscribe to a force update, and then here in the color, you say this.context.theme, get color. So you're snagging that right off of there. So even though the context that got passed down didn't update, you still have a reference to that object, and you can say get color, and that did change, and you're good to go. So my favorite part of this talk is how to egregiously abuse context, which you can do for lots of fun. So there's a lot of sneaky tricks that you can do with context. You can pass callbacks down the tree, and you can also pass callbacks up the tree. You can pass almost anything anywhere you want it. Take, for example, like a situation where you had children of undetermined depth that you wanted to identify, right? You could pass a function down via context, every single one of them that's like register me, right? And then in a top level component, you could have them call back home and register themselves. So rather than having to be a dork and go look through rendered DOM, you would be able to check your registration array of what had registered itself. Now you have reference to all those things. So I have a library where I abused context at a level that I've never even seen before, and we're going to go through how that works today. But it lets you do crazy things. It's a library called React Music. I don't know, some people may have seen it, but I never actually demoed it at a conference. I built it, never gave a talk about it. Somebody was like, "What did you build this for? You build it for a talk?" I'm like, "Nah, I was bored." But finally, I'm going to demo it. So let's look at what React Music does. Right? So I'm going to go to the first demo here. So what React Music does is it lets you basically make beats with React tags. Yeah. So you have something like this, like your song tag, right? So you have like a playing prop, you have like a tempo prop, or you could set so it's like loop-based music. So if you've ever used like like FL Studio or something like that, this is set up sort of like that almost. So within your song tag, then you have a sequencer tag, and this is like a step editor, right? So you can set the resolution. So for every bar, how many individual ticks are going to take place. And then you have bars, which is how many times this section should loop. Now within there, you start to get into some funnier stuff, right? You have your compositional elements. You have a sampler, right, which will take a wave sample and play that back, and you also have a synth. So the sampler, you're not going to really tune that up and down. I should probably add that, but whatever, it just plays it. So you have a steps prop, and because we have a resolution of 16. Here we're specifying based upon 16 steps over one bar. These steps are, it's an array of when that should play. So you have 0, 2, 8, and 10. Again, you have your snare on the 4 and the 12. So like, right. Down here on synth, it's a little bit different because you have your start, much like the sampler, but then you have a duration, like a hold, right? So these are all for 1 second there. And then you have your notes array. So here you could just do like a single note, or you could do a chord. You're seeing here like some triads and some individuals. But that's the general idea. That's the general API of how this works. Now, actually getting this to work is a whole different story. Some weird shit, so let's check this out. So this is your song tag, and this actually wraps up everything that's taking place. We have song extends component, but what we want to look at is our child context types here. So we're passing down an audio context, things like bar, interval, buffer, loaded, connect node, get master, scheduler, and tempo, right? So we want to pass down tempo. We want to have our scheduler. Our scheduler is what's going to schedule the notes. So if we're doing the loop, we're passing down a thing that is going to orchestrate calling all these different things in proper time, right? You don't want to have them individually running like set intervals on their own because, based upon component amount, the shit will be out of your beat will never sound on time for every single thing. So down here in the constructor, two of the most important things, so the way that the web audio API works is you create these things called audio contexts, and then things connect to it, right? So it's you can connect things all the way down. It's like a patch bay where you can connect in effects and inputs and everything like that. The context is the output, right? So here we create a top-level audio context in our constructor, and we create this scheduler, which we pass the context into. These both get passed down via context. The next most important one is sequencer. Sequencer doesn't actually do anything other than define that anything that's in it should abide by this timescale. Again, we have the resolution and we have the bars. And I can show that function in a little bit. But here we're just using props. What's funny is here we have get child context, right? So we're passing down bars and resolution. But in our actual context types, we get the master, which is the reference to the actual song component where we're storing things on the instance. In here on mount, we can go and we create a UUID. And then in master, we have the number of bars. So for every time we have a sequencer, we're going to go and we're going to store on this bars or I guess it's an object rather, by ID, how many bars that is. So then later on, what we can say is when we're doing our master loop, right, we have like 5 different sequencers, and they have this many bars. So we're going to go and do a max on that and see which one has the most bars, and that's going to be how many bars the main loop has. And then, if the main loop has 4 bars and this one has 2, then we're going to have to double this one up, right? So that's how you can have loop sequences of different length. Going down here to the actual meat and potatoes, so to say, is your sampler component. So in context types, right? I also have over here. There's a bunch of effects, right? We have effect buses, we have an analyzer, we have bit crusher, compressor, chorus, delay, filter, gain, LFOs, Moog filters, overdrive, ping pong. Is there anything that this cannot do? Each one of these is set up a lot like this, and the biggest point here, sampler aside, is this audio context. Because what happens in our constructor is we say this dot connect node, right? And here I'm going to create a gain. Right? I'm going to say context audio context gain. So we go and we say this connect node connect to context connect node. Right? So if we had our other thing and we passed it down, we're saying take our connect node and connect it to the one that's above it, right? And then in get child context, pass that one down. So now using this React tag tree structure, we're able to create this chained group of things that are going to create an audio signal. This is insane amount of context abuse, but don't worry, it gets worse. So, for actual instruments, when they play, here we get like the master, and then we store instruments in the master, and that is this get steps function, right? So we check out the steps that are listed there, and then in our scheduler, we're going to insert this dot play step at those times, right? So then you do a bunch of this nonsense to make sure that it's on time, but you're passing this back up the tree into the scheduler, scheduling a method on this component, which is play step, which creates an audio buffer, sets the sample to it, and then will eventually play it, source.start here. And then you disconnect it and clean it up. Also, we're doing this buffer loaded, so we're keeping track of, if we have these samples deeply, we don't want to start playing until they're all loaded, or it's going to sound garbage. So I keep track of buffers loaded. They identify themselves first and foremost, then they identify if they've loaded, and I can only start playing after all these buffers have loaded. So that's a crazy way to use context to do things that you probably shouldn't. But I had a lot of fun. And you guys want a demo? Okay, you want to make some hot beats? So like the one that's like built into React Music is cool because it has like a synth and everything, but it's kind of like it's all right? But I was walking over here today, I had my headphones on, and naturally I threw on some Jay-Z, and I was just walking, I was like, yo, this would be gangster if I remade this beat real quick, so I did in the speakers room, and the shit is going to be sweet. Do we have... Is there audio on? Let's bump that shit, man. Guys, we started off with a... All right. So I started off with a kick here, and you can see the resolution is 32, right? Because I wanted to have a little swing on it, like. So then I was able to use decimal values for like 14.75, so we could get that little pattern going. Out. I'm compressed. Yeah. Nice. Yeah, it happens. Let's put some snare in. It's an update after the full loop. So we have some hi-hats. America. So these are on different sequences. Right, this is a 16 resolution. This is on a 32, and the kick and the bars. The hat snare, that's pretty constant. But you want the kick to kind of have a little something. So then you want to do some samples. So I found this sample and cut it up. You need a letter from a record company. You guys ready? Yeah. Here we go. What, dude? producing for Jay-Z with React. I didn't have time to sample Aaliyah, but whatever. Yeah. Yeah. So, that's that. 2:40 on the clock. Am I doing any questions, or am I doing them? Or?
You're good for Q&A if you want to take a few questions.
Yeah, sure. I'll take questions if anybody has any questions. With Redux? Maybe? It might be. What? Oh, yes, if it was possible to do with Redux. Maybe? I think so. I mean, I think maybe. Yeah. It's certainly possible. Probably not the chain of connect nodes going down. That whole thing. Like if I wanted to register the buffers being loaded, that you could definitely do that in Redux. But as far as like mutating it on the way down contextually, probably not. Maybe you could. It would just be elaborate. Holla.
How much of that was just sadism versus needed?
How much of that was sadism versus needed? It was absolutely unnecessary. Yeah. But it was sweet though, right?
For the updates issue, you have the sort of pub-sub pattern.
Yeah.
Could you just pass down a mobx object and then you get notified when your theme changes or your color changes? Pass down a mobx object in context.
Yeah, I think the same thing happens with mobx, or at least it did. Yeah, I think mobx got blocked as well. Yeah, I mean, I don't know about now. I know that the last time that I was using mobx, I had an issue with that. And then they had like some fork of like a mobx pure component that compared on context as well as props. But yeah, the mobx objects you could do crazy shit with. I've taken those and passed them into physics worlds and then let physics worlds update them, and then you're listening to them and it moves stuff. And more? All right.
Hi. I was wondering, so the pub-sub pattern that you're using, is that kind of like, would you recommend that as kind of a workaround for people that are using in their own code bases? And then also, what's really going to happen with all these libraries or using it in a way that might be better?
So is the pub-sub the way that you should be doing it? And what is going to happen to all the libraries that aren't doing that?
I use like several libraries.
Yeah. So pubs. I mean, that's one way to do it. You have stuff like React Broadcast, which kind of does that for you. If you're an implementer, I mean, you'll generally do that. Yeah, it's going to be some variant of that pub/sub kind of setup. As far as the libraries that don't currently do that. I guess it needs to depend on if it changes. I mean, I think that, so I've been using context abusively for roughly 3 years. And like the whole time they're like, but it's going to change, it's going to change. And after a while you're like, yeah, okay, buddy. But, when it eventually does, I mean, we're JavaScript developers. We love to update shit, I'm sure they'll all get it up to date. And, even if they don't, you could use the third-party thing like React Broadcast to mitigate that.
There's one in the back there.
No. I mean, it's like they say like they're gonna do it, but I thought that it would have been in Fiber personally, but I mean the next thing on Fiber is the actual async stuff, so. I mean, I'm sure they'll cross that context bridge at some point, but there's bigger fish to fry at the moment. You good? Anybody?
All right, looks like that's it. Let's give them a round of applause.
Thanks so much, everybody.